Okay, so on to section 1.2. And with 1.2, we are going to be looking at solving multi-step equations. So multi-step just meaning more than one, more than the simple equations that we've been doing. It's going to take into account the combining like terms, the distribution, all the simplifying that we've been doing. So this is going to be section 1.2. These will be some notes. And this is solving multi-step equations. And again, multi-step equations are just, it's going to be more than one. There's going to be a process that we're going to follow. I'm going to make a star right here. When you are dealing with multi-step equations, we first are going to simplify each side of the equation if necessary. It will not always be necessary to simplify both sides first. The other key point is then use inverse operations. We're going to use inverse operations to solve these. Best way to do these, just look at some examples. I have 2.5. 2.5 times x, subtract 13, is equal to 2. This is actually going to be a two-step equation, but what I'm always going to do is go through this thought process of how we solve this. Looking back at my statement up here, I need to simplify each side of the equation if necessary. So I'm going to look at the left and the right. And I'm going to ask myself, is there anything that I need to simplify on the left or the right? Is there any like terms to combine? Is there any distribution that needs to happen? In this case, there is not. So the way that we solve these and the way that I go through my thought process is I first ask myself, what is happening to x here? If I had a value for x and I wanted to check it, let's say x was equal to 1. What would happen if I plugged in 1 to this equation for x right here? Well, I would multiply it by 2.5, and then I would subtract it by 13 if x was equal to 1. Why would I do that? Because I follow order of operations. Multiplication, 2.5 times the x, and if the x is equal to 1, comes before subtracting 13. When we are solving and when we are isolating the variable, we need to reverse these order of operations. So what I like to do is just start out and say, what's happening to that x right there? Well, it's being multiplied. I'm going to use a little dot for times there. It's being multiplied by 2.5, and it's being subtracted by 13. Those would be my steps if I plugged in a value for x, following order of operations. In order to solve, you need to reverse those. You need to reverse those. And you reverse them using inverse operations. Inverse operation of subtracting 13 is adding 13. The inverse operation of multiplying by 2.5 is dividing by 2.5. Those are the steps that I need to follow in order to solve this equation. I need to use inverse operations, and my steps will be to add 13 and then divide by 2.5. First step, add 13. What I do to one side of the equation, I must do to the other. I'm going to stay nice and organized. Nothing's happening to this 2.5 right now. That's going to stay right here and come down. So I'm left with 2.5x. I have a negative 13 plus 13. That's 0. That's what I'm looking for. That's why we use inverse operations. What I did to one side, I must do to the other. So if I add 13, I added it here. My equals is still here, and I have 2 plus 13, which gives me 15. Now I'm back to just a simple one-stepper, which we did a bunch of. First step was to add 13. Second step, divide by 2.5. That makes sense because x is being multiplied by 2.5. In order to undo multiplication, I use division, so I would divide by 2.5. And what I do to one side of the equation, I must do to the other to make sure that these are equivalent. Both sides of the equation are equivalent. I would take my calculator, put in 15 divided by 2.5. And it gives me an answer of 6. I can absolutely test this and plug it back in. I would take this 6 and substitute it right back in there for x. Here's where that order of operations comes in. It's 2.5 times x, which happens to be 6, subtract 13. And I want to know, does that equal 2? Well, if I take 2.5 times 6, and I subtract 13, my calculator will certainly do that. It says it equals 2. So this is 2. It equals 2. That checks, and I can box in my answer. Next example. Negative 12 is equal to 9x subtract 6x plus 15. And again, I'm going to go right back up to that statement that's up there. Simplify each side of the equation if necessary, then use inverse operations. Nothing to simplify on the left, but on the right here, I definitely have some simplifying to do, and this goes back to what we've been working on for the last week. Brushing up on our distributing and combining like terms. I absolutely have some like terms that I can combine here. I have a 9x and a minus 6x. That's what I mean when I say simplify each side first. If I can put these x's together, then I can isolate that x and solve for it. First step on this one is you are going to combine these like terms right there. I have a 9x minus a 6x. My negative 12 would stay the same. 9x minus 6x, well, 9 minus 6 gives me a 3x, and I have my plus 15. Now I'm right back to where I was right up in the first example. I've got a two-step equation. Again, ask yourself, what's happening to x? Well, x is being multiplied by 3, and then it's being added by 15. You need to reverse those in order to get x by itself, which means my steps will be subtract 15 because of the inverse operation of addition is subtraction, and divide by 3 because the inverse operation of multiplication is division. These are the steps that I follow to solve. First step is going to be subtract 15. I subtract 15 from both sides of the equation. I've got to maintain that equality. What I do to one side, I must do to the other. Big mistakes happen here. Negative 12, subtract 15. Negative 12, subtract the subtraction sign right here. 15. I'm combining two negative numbers, which means I am getting farther to the left on the number line. I'm at negative 12 and I'm going 15 farther to the left. That gives me a negative 27. That's going to equal 3x. That goes away. The inverse operation, when I add and subtract the same thing, it becomes 0. Now, I just have a simple one-stepper. X is being multiplied by 3 to undo multiplication. I divide both sides by 3. That's going to leave me with -9 is equal to X. Or, if you can't stand it, you can write it as X is equal to -9. And you can absolutely check that on your calculator. If I plug in this -9 right back to the first equation, I want this to equal -12. So I could take 9 times -9, subtract 6 times -9 plus 15. Whoops. 15. I'm hoping it tells me it's -12, and it is. -12 indeed equals -12, and I've got it. Next example. -2n plus 3 is equal to 9. Then I have this example. -2x subtract 10x plus 12 is equal to 18. Get those written down. I would pause the video, give these two a try, and then come back and see if you got them right. All right, hopefully those went okay for you. I'm gonna look at this one on the left first. Simple two-stepper. Ask yourself again, what's happening to n? N is being multiplied by -2 and added by 3. It's being multiplied by -2 and added by 3. Multiplied by -2 and it's being added by 3. You need to reverse that, which means you would use inverse operations to subtract 3 and divide by -2. Those are the steps that I use to solve this equation. -2n plus 3, I would subtract 3. -2n comes down. Inverse operations takes care of that. That's what I'm looking for. 9 minus 3 is 6. And now I've just got my one step to finish. N is being multiplied by -2. You need to divide both sides by -2, which leaves me with n then is equal to positive divided by a negative is a negative. 6 divided by 2 is 3. Solution, -3, and you can absolutely check it. Plug it right back into your original equation. -2 times -3. Well, negative times a negative, that would be a positive 6. 6 plus 3 does indeed equal 9. That checks. I'll box it in. This one, just like our second example over there. I've got some like terms. Combine them. Simplify first, just like our statement at the top. Simplify each side first. I definitely can simplify the left here, but not the right. And I've got some like terms. Those right there. -2x subtract 10x. I'm at -2, and I'm going to the left on the number line 10 more. That would put me at -12x plus 12 is equal to 18. And again, ask yourself, what's happening to x here? X is being multiplied by -12 and added by 12. You need to reverse in order to solve, which means inverse operations. I subtract 12, divide by -12. Steps are going to be to subtract 12. What I do to one side, I do to the next, the other, excuse me. Negative 12x would stay. That takes care of that. 18 minus 12 is 6. Next step would be divide by negative 12. What I do to one side, I must do to the other. X then would equal 6 over negative 12. This is not simplified. We're always going to have to simplify. 6/12 reduces to, or 6 divided by negative 12 is a negative 1/2. Or you could have negative 0.5. A decimal would be fine in that case as well. Those two are your acceptable answers though. The reduced form of it. I'm going to flip my paper over and we're going to push on back to what we did the last weekend's class here. Why did we brush up so much on distribution and combining like terms? Because it is going to come into play when we do these multi-step equations. I have 2 times the quantity x, 1 subtract x plus 3 is equal to negative 8. I can see right now I've got some distribution. This 3 is not included in this distribution because it is plus 3 off the back. It is saying 2 times this quantity of 1 minus x. We need to distribute first. We need to distribute. 2 times 1, 2. 2 times negative x, a negative 2x. And I've got my plus 3 is equal to negative 8. I should have been thinking right away too. When I multiply this out, I know I'm going to have some like terms. I've got a 2 and I've got a 3. There's my like terms. There's my 2 plus 3. My negative 2x would stay. 2 plus 3 plus 5 is equal to negative 8. Now I'm right back to my 2-stepper. X is being multiplied by negative 2 and added by 5. You need to reverse those, which means you need to subtract 5 and divide by negative 2. Now, do you have to write this step down every single time? Absolutely not, but you should if it is helping you solve this. We're going to get to the point where I'm not writing that out. I can look at this and know that I'm going to use inverse operations, and in order to get this x by itself, I start getting stuff away from the x until that last step. My steps say I should subtract 5. What I do to one side, I must do to the other. Negative 2x would come down. Inverse operations takes care of that. And now I have negative 8 subtract 5. Negative 13. Check it on your calculator. Use your calculator. Negative 8 subtract 5. Negative 13. Next step, x is being multiplied by negative 2, so I would divide by negative 2. X then is equal to negative divided by a negative is 13 halves, or 2 goes into 13 6 times. I have 1 left over, so it would be 6.5 or 6.5. And you most certainly could take that 6.5, plug it in right there, and you should get negative 8. Calculator again will do that. if I take 2 times the quantity and put it in just like I see it, 1 minus 6.5, close my parentheses, plus 3. When I hit enter, I'm hoping that's negative 8. And it is. And it checks, and I boxed it in. I'm going to write this next one out. 3 times the quantity x plus 1 plus 6 is equal to negative 9. Go ahead and pause the video. Give this one a whirl. Come back and see if you got it. Hopefully it wasn't too bad. Hopefully you discovered that you had some distribution. 3 times x is 3x. 3 times 1, positive 3, plus 6 is equal to negative 9. You've got some like terms right there to combine. 3x plus 9 is equal to negative 9. X is being multiplied by 3 and added by 9. You need to undo these by subtracting 9, dividing by 3. Get this x by itself. In order to get it by itself, I subtract 9 first. 3x would stay. Inverse operations takes care of that. Negative 9 subtract 9, negative 18. I would divide both sides by 3. X then would equal negative divided by a positive is a negative. 18 divided by 3 is 6. And again, I can plug that right back into my original equation and see if I got it right. 3 times the quantity, negative 6 plus 1, close my parenthesis, plus 6. I'm hoping that equals negative 9. And it does. I get a true statement. Negative 6 is my solution. Last example. Negative 4 times 2m plus 5, subtract 3m is equal to 35. Go ahead, pause the video again. Take a minute or two, distribute, combine like terms, and solve for m. Hopefully this worked out for you. Hopefully, again, you noticed you had some distribution. Negative 4 times positive 2m, negative 8m. Negative 4 times positive 5, negative times a positive would give me a negative. 4 times 5 is 20. And I've got my minus 3m there still is equal to 35. And again, notice this negative 3m is on this back side, just like this 6 is up here. I don't distribute that negative 4 to that negative 3m or that positive 6 because it's not next to it. It's not implying multiplication, it's addition. This implies multiplication. It's negative 4 times that quantity. You got some like terms. Negative 8m, negative 3m, those need to be combined. Negative 8, subtract 3. Negative 11m, subtract 20 is equal to 35. And here we go again. You got to get this m by itself. M is being multiplied by negative 11 and subtracted by 20. You need to reverse those, meaning inverse operations. My steps are add 20, divide by negative 11. Step 1 told us to add 20. Negative 11m will stay. Inverse operations takes care of that. 35 plus 20. Well, 35 plus 10 would be 45, plus another 10 would be 55. M is being multiplied by negative 11. to undo multiplication, I would divide by negative 11, and that's what I expected based on what I wrote up here. That leaves me with m is equal to positive divided by a negative is a negative. 55 divided by 11 is 5. And again, you can check it using your calculator. Negative 4 times the quantity, 2, and I've got times that negative 5 plus 5. I would close my parentheses. Subtract 3 times negative 5. I'm hoping when I hit enter, that equals 35. And it does. I checked it. I know it's correct. I box in my answer. We are going to be working on multi-step equations for the days to come. This will be your roadmap to answer those questions.